Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Tom Sarfi, Business Development Manager at Pickering Interfaces. We discuss the differences and similarities between PXI and LXI and why each is best suited. Tom dives into the considerations that need to be made when deciding which platform is best, providing some great examples and use cases for both, and finally concluding with his expert opinion on where he sees the future of modular instrumentation heading. Let's get started. I'm pleased today to be joined by Tom Sarfi, who is the Business Development Manager at Pickering Interfaces. So thanks very much for joining us, Tom. How are you?
Doing well, thanks.
Good. Why don't you start by introducing yourself and telling us a bit about your background?
Sure. My name's Tom Sarfi. I am the Global Business Development Manager for Pickering Interfaces. I've been in the test and measurement industry for about 38 years now. Started out as a test engineer many years ago before moving into industry. I've held various positions within organizations, whether it's product management, applications engineering, management, and so on. I've been involved in various consortia over the years. For a while, I was PXI Bus President, or the PXI Bus Consortium President. I currently sit on the board of the LXI Consortium and have been a board member of the PXI Consortium as well.
Excellent. And for those of our listeners who perhaps aren't familiar with the company, why don't you tell us a bit about Pickering Interfaces as well?
Sure. Pickering Interfaces was founded in 1988. We started out as a supplier of precision switching systems. So for automated test systems, signal switching is a key component of that. This was kind of born out of the original company, which was Pickering Electronics, which is still in existence, which manufactures relays for instrumentation. So we've been providing modular instrumentation since 1988. We've expanded our portfolio beyond signal switching into instrumentation, particularly sensor simulation, and we're very active in producing our products to open industry standards.
Excellent. So today I'd love to talk about the differences between LXI and PXI and where each is best suited. So PXI and LXI are the predominant industry standards in the automated test industry. So can you explain for us the fundamental similarities and differences between these two standards?
Yeah, sure. Let's start with the similarities. Probably the obvious thing is that the foundations are based on technology that we would consider to be ubiquitous in the consumer world. So the P in PXI stands for PCI bus, and LXI, the L is LAN. So both very common technologies in the consumer world. Both standards add extensions, though, to those common consumer technologies that become relevant to the test instrumentation world. Both are supported by multiple vendors. Each has a consortium that presides over the specification and strategic planning for future direction. And the objective is really to achieve vendor interoperability to ease systems integration. Both standards actually took the baton from a legacy standard. In the case of PXI, that legacy standard would be VXI, which was a card-based standard that was introduced in 1987. And then LAN or LXI is really the successor to what was originally HPIB and then evolved into GPIB. Both standards have really been evolving over the years while maintaining backward compatibility as well. And I guess if we start really looking at the differences, the obvious difference is that PXI is card modular by definition, with strict requirements on how mainframes are constructed, how they're powered, how they're cooled, as well as module form factors. Theoretically, any supplier's module should work in any other supplier's chassis, and vice versa, assuming the chassis meets module's cooling and power requirements. LXI is primarily a standard for communicating to an instrument over Ethernet. The LXI base, or what we call core specifications, are intended to provide consistent behavior of LXI devices when plugging into a test network, really kind of ensuring that an LXI device is a good neighbor to all other LXI devices on a network. But then the spec goes a bit further and defines extended functions that are optional to support. And it leaves the mechanical implementation of the design up to, for the most part, up to the vendor. LXI specifies a minimum software driver requirement as well. All LXI devices must be delivered with an IVI driver, another industry standard, interchangeable virtual instrument, though the LXI spec does not restrict vendors to only an IVI, providing only an IVI API. In fact, LXI instruments work in many different application development environments and operating systems, and I think that's part of what drives its popularity. Finally, LXI has a very rigorous process as defined by the LXI Conformance Committee within the consortium that a vendor needs to go through to be able to claim that their device is LXI compliant. Member companies, we as a member company also funded a reference design that's intended to make it easier for new members to obtain LXI certification on instrument designs. So that kind of just summarizes, in a nutshell, the basic similarities and differences between the two standards.
No, fantastic. Thank you. And you defined PXI as a modular standard. So what advantages does a modular standard offer to test system architectures? And then how can the concept of modular be applied to the LXI standard?
Well, modular architectures are everywhere, not just test and measurement. I mean, they're found in the construction industry, the computer industry, or the computing industry. It's how many software architectures are defined. But as it relates to the test industry, I'd say quite often the products we're testing are modular. So, as an example, flight control computers, they're typically modular in nature. And in the US, DoD code, modular is actually mandated through something called the Modular Open Systems Architecture, or MOSA. It's an acquisition strategy that promotes modular design, open standards, and interoperable components within defense systems. But to address the question, what potential advantages does modularity bring to the table? It's a building block approach fundamentally that offers reusability of components and reconfigurability. It provides the potential for significant cost savings, schedule reduction, rapid deployment of new technology. There's the opportunities for technical upgrades and refresh through modular architectures, as well as interoperability, including what we call system of systems interoperability and mission integration. Within test, it's not a new concept. It's been around for many, many years, as long as I can remember. But we can frame this discussion, say, around an open chassis card-based modular platform, which is really what PXI inherently is, versus a proprietary box modular platform, where a test track is comprised of function-specific discrete devices, which is where LXI plays a role. And then in the context of test and measurement, there's many advantages to implementing an open modular architecture like PXI in system designs. First and foremost, taking on the general advantages of borrowing from the general advantages of modular instruments, PXI facilitates scalability and design flexibility. There's a range of chassis options and sizes. Chassis can be configured to application-specific requirements. You can leave within a design open slots so that you can allow for future expansion, which promotes scalability and then ease of technology insertion. And then there's different test functions that can be created by reconfiguring different hardware building blocks and defining the capability of how these building blocks are going to work together through software. Years ago, there was a term called synthetic instrumentation, which was coined to kind of describe this aspect of modular. And while LXI doesn't really define a strict mechanical definition, it also doesn't preclude a card modular implementation. And it's really up to the vendor to decide whether a modular implementation is best suited for the applications that they're targeting. In our case, in Pickering's case, we can create a versatile switching subsystem with an LXI interface that is comprised of switch modules that either switch low-level or high-level signals in a range of frequencies from DC to light. But there's many other examples out there of modular LXI products, just as there were modular products with a GPIB interface. One of the first instruments I worked with was an HP 66000, which was a modular DC power supply with a GPIB interface. This was then superseded by, a Keysight came out with a modular power supply, the N6700, that has an LXI interface. You can also consider modular these little half-rack 1U oscilloscopes. That is, considered to be, say, a basic building block in a test system. But there are also, a variety of card-based modular LXI data acquisition systems, and this is where we start to see subtle differences between LXI and PXI, and they become a little bit more apparent. LXI card-based platforms are generally not multi-vendor interoperable. So what that means, what I mean when I say a LXI card-based platform, I'm talking about a chassis that looks like a PXI chassis, may have cards that look like PXI modules, but they're not that chassis does not support multiple vendors. It's usually restricted to a single vendor's modules that can plug into that chassis with an LXI interface. In our case, in Pickering, we have PXI switch modules that can plug into a chassis that looks like a PXI chassis, but it has an LXI communications interface to talk to the box and to the switches in there. But really, even though those modules are PXI switch modules in this chassis, they're really only Pickering PXI switch modules that can be housed in that mainframe. That's different than PXI, where these same switch modules we make can plug into a PXI chassis and sit next to a DMN from Keysight or National Instruments or other PXI instrumentation. That's kind of kind of where we see some of the advantages and some of the differences in terms of modular.
And how would you best describe LXI, Tom? Do you consider it to be a platform?
Well, PXI is referred to as a platform because it's got a very well-defined mechanical and system architecture, but LXI is more, I'd say, generally considered to be a network-centric interoperability standard, not a platform, more of a standard. That said, LXI can exhibit platform-like behaviors because while it defines a core specification list, it also defines extended functions. That's the X in LXI, which are intended to implement coordination and communication between instruments. Mainly, a couple of the extended functions are a wired trigger bus, which allows for hardware handshaking between discrete LXI devices, and then it also defines IEEE 1588, or the Precision Time Protocol, as a mechanism for ensuring all network devices are time synchronized. So it's not really a platform as we would typically define a platform to be in an automated test environment, but it's definitely a standard that extends generic LAN's applicability for use in test instrumentation.
And given all you've said so far, what considerations should be made when deciding which platform is best suited for a clean sheet ATE system design?
Well, the first thing to do is consider the high-level objectives you are trying to achieve with a test system project before you even really consider platforms or standards. I mean, for example, is the project going to support a single application, never to be used for anything else? Or is the intent to develop an architecture that can support needs today and into the future? Is it possible that there'll be various applications of a test system? In other words, shared technology within a test system design for design and validation purposes, and then migrating that into production test. Is the footprint of a test system of concern? How long do you need to support the system? Are you considering total cost of ownership through sustainment? Is it possible that you want to adapt new technology for future unknown requirements? So there's a lot of things that you need to, starting from the clean sheet, consider before you even start looking at platforms or standards. In fact, I would say one of the last things you should be doing is locking into a specific platform or off-the-shelf solution for that matter before all project goals are considered. Finally, though, I think the most important thing is that we're talking PXI and LXI, and if you think about it, a Venn diagram, there's some overlap, but most systems employed today or deployed today use a combination of LXI and PXI. It's not you pick one standard, it means you can't use the other standard in a test system. Certainly hybrid systems are, I would say, the norm.
Can you perhaps give us some specific examples of applications that are better served by the LXI platform and tell us why?
Well, being a company that has, Pickering has an extensive portfolio in signal switching, we've got exposure to a wide variety of applications, because our switch cards might be switching low-level signals, sub-milliamp, could be switching signals up to 40 amp with signals, going from DC to 110 gigahertz or even optical signals. A card modular platform could be LXI or PXI. That's ideal when creating, specifically in a switching environment, a mixed signal switching subsystem. There are definitely those certain applications that are space hungry, and whether it's a 3U or 6U Eurocard standard, it just won't provide the sort of real estate that's needed to efficiently address certain requirements. In other words, I talk about laws of physics come into play, and those laws of physics pit two competing goals against each other. One being a goal to try to achieve as much density as you can in your system design. The other goal being trying to maintain excellent signal integrity. Those goals can be competing with one another, and when you have a very defined 0.8-inch pitch center spacing for these Eurocard standards we're talking about, PXI specifically, there may not be room for certain connector sizes or relays, to really handle it efficiently. So that's where LXI comes into play. Specific examples, as I mentioned, could be switching high current, very large relays, large connectors, high voltage, where you need to provide switching high voltage signals where you need to provide enough spacing between connectors or connector I/O, complex RF signal routing and distribution networks, and then certainly, I kind of touched on power supplies or loads of any substance. It's going to be very difficult to implement a 300, 400, 500 watt power supply subsystem in a PXI form factor. It's just not economical or efficient.
Mm. And you mentioned that nothing in the LXI standard prevents modular implementations. So what advantages could a modular-based LXI solution offer over PXI? And why would someone choose an LXI modular implementation over PXI?
There's a few reasons in addition to addressing, the space-hungry applications that I just mentioned as to why an LXI modular implementation might be more attractive than PXI. From our perspective at Pickering, we have the PXI modules that I mentioned that can plug into a native PXI chassis or the chassis that's been adapted with a LAN interface that connects back to a host. So I would say that's probably a good apples to apples use case for comparison, because they, from looking at it from the outside, they look the same except the way you connect up to the box. With LXI, it's really the simplicity of Ethernet that's attractive. You can plug an Ethernet or an LXI instrument into any Ethernet switch, discover the device using a discovery tool that the LXI consortium distributes for free on their website, type an IP address into a browser, and start communicating with a box using supplied HTML page. There's also cost to consider. LXI modular implementations are typically tailored to really address a specific set of applications. Again, in our case, switching. So the mainframes don't necessarily, they can be, really designed around those specific applications. Whereas a PXI chassis, needing to support multiple vendors, solutions, and multiple applications, it needs to handle a very diverse range of requirements. So again, contrasting the two, a PXI chassis will often incur some overhead that's associated with power, maybe the control interface, the backplane infrastructure, that might be overkill and drive unnecessary costs. So signal switching, as an example again, for this use case, doesn't require backplane speed that PXI brings to the table. It doesn't require a fast interface to the PCI bus. So we can make a economical LXI chassis that is really tailored to meet the designs that we are doing. And then to illustrate just the size advantage, going back to that, I had mentioned on space-hungry applications, maybe to use a specific example, we build microwave relay switch boxes. And microwave relays can be pretty large, physically large. So if you're trying to fit them on a front panel of a PXI module, that can be quite a challenge. You end up with a lot of wasted space. And a specific example that we've had recently, we constructed a 6x6, 26.5 gig matrix that was using self-terminated relays. Looking at that in a PXI implementation would have taken two fully loaded 4 rack U chassis where we could achieve the same thing in an LXI box in a 3U footprint. So a lot of, it's really what you're trying to achieve, and it becomes pretty apparent. I think it would become pretty apparent when LXI has an advantage over PXI when there is that overlap in applications.
I know that one of the advantages of LXI is its ability to function in a remote or distributed environment. So can you elaborate for us on why this is the case and possibly provide a few examples of LXI being used in a remote setting?
Uh, yeah, for sure. I mean, this is a huge advantage to an LXI, to the LXI standard or for the LXI standard. Traditional rack-based test systems used in production tests, they're quite appropriate for scenarios where the devices to be tested tend to be co-located with the test rack. So you might, the device you're testing could be put right up next to the test rack or, mounted to the test rack. So that, a traditional rack-based system is that makes sense in a case like that. But if you're setting up a data acquisition test where a test article could be a very large structure and there's thousands of distributed sensors to connect to, then a central rack-based system has some baggage. Think jet engine test cells, wind tunnels, or the validation of the structural integrity of an airframe as real-world examples. There could be hundreds of feet of hundreds and thousands of expensive cables between sensors and the centralized test rack, which drives up costs, compromises signal integrity, and all the cabling presents a maintenance challenge as well. But since LAN is inherently a distributed architecture, LXI instrumentation can then be strategically placed near the measurements to be made. And then Cat5e is the cabling is really being then used for the long haul cabling back to the central processing system. Or even a wireless connection between the host PC and network instruments is possible. So there's a huge advantage there. It is important to note, though, that when you have a distributed measurement system, so multiple LXI boxes could be tens or hundreds of feet apart from one another, it's usually required that these network instruments be tightly time synchronized to avoid channel-to-channel time skew. And with a PXI-based system, that's inherent through the PXI chassis and its shared clock. Distributed LXI devices that need to be tightly time synchronized will typically achieve this through implementation of the PTP, the Precision Time Protocol, or IEEE 1588 extended function. So if you're distributing your LXI instruments and you want them to be tightly time synchronized, you're going to want to make sure that they have implemented the IEEE 1588 extended function. And then one other advantage in terms of distributing, the distribution of the instrumentation that LXI brings to the table, it also facilitates sharing of resources within a development organization. Devices can be easily accessed over the corporate LAN by multiple developers to help reduce development costs.
Following on from that then, Tom, I'm interested to hear if there are any particular trends driving the adoption of LXI in industries such as military and aerospace or automotive, for example.
Well, LXI has been around since, I believe the standard was first put into play in 2005 or 2006, one of those years. And it's really, at this point, it's already well established and it's, prevalent in mil-aero test systems. And we really touched on a few of the reasons already why it's gained popularity. There's significant value in the distributing of the instrumentation, as I just mentioned. There's also just some functionality that's not available in PXI. Also touched on that. But beyond that, there's an increasing push for faster time to market with fewer resources, which is putting squeeze on test integration engineers. So whatever can be done to reduce schedule risk is seen as advantageous. So the rigorous conformance testing that LXI devices need to go through helps here and satisfy this in that all LXI devices will behave consistently on a network. So that makes that takes a little bit of the uncertainty during integration of devices off the table. The LXI consortium also addressed recently with the latest release of the specification cybersecurity concerns, which is a big deal in mil-aero. So there is an extended function that was just introduced that defines how LXI devices are to operate to secure communication to the devices over LAN. But I'd say in short, the benefits that exist with an industry standard, anytime there's an industry standard that just takes a measure of uncertainty off the table, and particularly in this case, these standards are geared towards test and measurement. And that just makes for the industries like you mentioned, the mil-aero and automotive, that just makes LXI more attractive than vanilla LAN and is really, or generic LAN. And that's really been increasing the adoption.
What are the cost and footprint considerations when integrating LXI into existing test systems?
It really comes down to the type of functionality that's needed. But unlike PXI, LXI doesn't dictate a form factor, as we've been talking about. And one thing to consider is how important is it to have physical controls and displays? That is probably, I mean, if you were to pick up a PXI oscilloscope and compare it to a box oscilloscope, that's one of the first things you'll note. I mean, that's the first thing you'll notice is that there's a display and there's knobs on a box oscilloscope. On a PXI, that doesn't exist. But PXI, instead of using, because they don't have the physical displays, they'll emulate those through virtual or software and panels. And while the elegance of these virtual panels is significantly improved over the years, there's still instances where those physical controls are desirable, particularly in a factory floor environment where instruments such, like I said, as an oscilloscope, pull double duty. They'll function as a, part of the automated test, but they'll also function as a tool for a technician. And technicians love to twist knobs, see something right on the screen right there. So even though while it takes up a lot more space, the efficiency in being able to manually control the device might be worth it. If we look at the cost, let's say you've decided on PXI and that's going to be part of your test system plans, and your application requires the horsepower that a Generation 3 backplane brings. A Gen 3 chassis and controller, you can think of it as, you think of it as you're looking at cost. Calculate that chassis and controller, because they're really doing nothing in terms of from an instrumentation standpoint, as a tax on an instrument that goes into a slot. So for an 18 slot chassis, this could be a tax of 1K per slot, or a premium of 1K per slot, about $1,000 per slot before you even plug an instrument in there. So it's not much of a premium if that instrument going in there is like a vector network analyzer or an RF signal generator, which really needs that Gen 3 speed on the backplane. But that effective cost per slot on something like a multiplexer switch from Pickering, which doesn't need those Gen 3 speeds, that could be significant, a significant cost driver. So if you were to pull that functionality out, say the signal switching out of that chassis, you now free up slots in your Gen 3 chassis for devices that need that speed. And now you can put those devices into an LXI mainframe and you effectively reduce that premium by as much as and even more than 50%. So it could be a considerable cost advantage in implementing it that way.
Brilliant. And you mentioned earlier that VXI is the predecessor to PXI, and it's clear that VXI is well into its sunset phase of viability. So do you have any experience to share with real-world scenarios where VXI-based systems have been transitioning to PXI or LXI?
Oh, yeah. Yeah. I mean, VXI was an excellent platform in this day. I was introduced to it as a test development engineer back in the early 90s, writing test programs with National Instruments LabVIEW 2.0, which at the time was only available for Mac. I guess the irony there is that Emerson just announced that LabVIEW for Mac is back now at this year's NI Connect. But VXI was an excellent modular platform. But as technology allowed for more complex designs to be achieved in smaller footprints, PXI, which was introduced in 1997-98, started eating away at its market share as a low-cost alternative. But even though it's been years since the last new VXI product was released to the market, many years, I'd say 6 to 8 years since we've seen the last new VXI product on the market, and many vendors have ceased production on their VXI portfolio, there are still many systems out there which have long life cycles that still have VXI products in their designs. PXI as a modular architecture is a natural migration path for systems facing VXI obsolescence, and it's really the most traditional approach to take. It's not too hard to find a PXI replacement, for example, for any VXI, for most VXI modules. A 6.5-digit DMM that was available on a 6U VXI module designed in the 90s is now easily available with similar or better functionality and capability on a 3U PXI module. And we've replaced many VXI switching subsystems with PXI platform products, often slot for slot. That's PXI. LXI is also playing a role, we're finding in system migration as well. One example I can give is a major mill aero test platform. here was in the US was facing VXI instrumentation obsolescence. The switching in that VXI chassis was still viable in production, but there was no room in the rack, but the instrumentation had gone obsolete, and there was no room in the test rack to leave this 8U VXI chassis and add a 4U PXI chassis. There just wasn't any room. And anyway, the switching was too complex to be housed in a single PXI chassis anyway. But in this case, we were able to migrate the switching to a 2U modular LXI box, while the instrumentation went into the PXI chassis. So we were able to migrate instrumentation, well, the end user was able to migrate the instrumentation from the VXI chassis into a PXI chassis. We provided the LXI switch. So it's a 2U LXI switch, a 4U PXI chassis. In the process of doing this, we opened up 2U of rack space for future expansion for this customer. They were looking to do technology insertion in the future.
Brilliant. Some great examples. So as we look to wrap up then, Tom, I'm interested to hear, where do you see the future of modular instrumentation heading, and what potential advancements can we expect?
From Pickering's perspective, we are fully invested in modular products. It just makes sense for the applications that we target. And it's whether they're implemented with an LXI communications interface on it or in a PXI chassis. Modular architectures just make sense. Think of them, again, just, in summary, think of them as just building blocks that can be reused or adapted for different applications. Signal switching is one of our core competencies, and since there's not a one-size-fits-all for all requirements, again, it's really just a modular is a natural fit for us. If we just focus on PXI and its future, I think it'd still be helpful to kind of go revisit and do a postmortem on VXI, which had a pretty extensive run as the dominant modular standard in test. I'd say 20 to 25 years or so of active product development. Difference here is it relied on a core technology that was not widely used outside of test and measurement, meaning it was limited somewhat in how forward-looking and future-proof it could be. So we contrast that to PXI. We've already seen PXI go through an evolution. It was first introduced, it was leveraging the PCI bus, but then PCI Express came into the fore, and there were significant advancements in technology. PXI Consortium leveraged that quickly, adapted it to the PXI specifications, and then injected new life into the platform. So crystal balls are only so reliable into the future, right? So, saying that, I would say PCIe continues to evolve, and it currently exhibits quite a bit of vitality. And again, unlike VXI, the foundation of PXI is not really showing any signs of cracking. We're more than 25 years after the inception of the standard, and the vendor community is still actively releasing new products, which to me is really the telltale sign of a platform's health. It positions it well, I would say, to adapt to new technologies that are being introduced to the market that drive new test paradigms. All that said, I believe the market for an open standard will remain strong, just mainly because proprietary modular architectures can be seen as restrictive, whether it be finite options in module selection or reluctance to being locked into a single source supplier. But probably the one thing is about as close to being guaranteed as you can get. As I mentioned before, hybrid systems are a reality, and those that implement different standards like LXI and PXI, they'll be around for a long time, since no single platform or standard is best suited for every test system requirement that's out there.
Excellent. Thank you very much for that. Is there anything else you would like to add, Tom, before we finish?
I don't think so. I think we covered quite a bit.
Yeah, we certainly did. Thank you very much for your insights. I know our listeners will certainly appreciate it. And it's been a pleasure having you as a guest. So thank you very much, and enjoy the rest of your day.
Thank you.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.